Hi, this is Purnima Magalingam, and you're watching video lecture series on solar wind energy system. In this video lecture series today, we are going to discuss about solar passive heating and cooling system, which is harness nature for thermal comfort, which comes under the topic of solar thermal systems. Okay, come, let's go into the video. Here, first part comes the empathy. So, the how building design can integrate with solar energy for climate control, which learns about reducing heating cooling loads by 20 to 80 percentage. Discovers how these systems are key components of high performance and net zero energy building. Our ultimate aim is a net zero energy building. So, this is what our ultimate aim. What is an empathy problem is? Now, coming to the process, understanding of this empathy. Here comes the solar thermal system, which captures, here comes the solar thermal system, which capture and utilize solar radiations for heating and cooling, which have an active systems using mechanical equipments, using mechanical equipments, sorry, mechanical equipments like pumps, fans, and heat for heat distributions. And we have a passive systems which utilize building design elements to nature regulate temperatures, and the well-designed passive system which can reduce energy consumptions about 30 to 70 percentage when compared to conventional home systems. This is what understanding of solar thermal system. Here next comes to the core principles of passive solar systems. So main principle is building orientations, thermal mass, glassing, super insulations and shadings. Here comes the maximize south facing exposures for winter solar grains and materials absorb, stores and release heat slowly, but this mass, thermal mass and high performance windows optimize heat transfers and high R values, roof foundations, etc. So shading, which is an overhang fence and which vegetation blocks under every some unwanted summer suns, etc. These are the core principles of passive solar. And now here comes the passive solar heating strategies. So we have three main strategies of direct grain and indirect grain and isolated gains, which is our sunscape and greenhouse. So direct gain is a south facing window admits sunlight into thermal mass of floor walls with storage of 60 to 70 percentage of solar heat. So indirect gain is south facing walls with a glass created solar air collector which reduce 50 to 70 percentages. And we have an subscape and greenhouse which attaches glass room collectors, heat transfers, can heat adjust with the room temperature of 10 to 20 per degree Fahrenheit. These strategies can reduce the demand by 30 to 70 percentage annually. Next, here comes the process. Here comes the process. Here it is. We have a passive solar heating strategies, which is a natural ventilations, shading the devices, external overheating, and external overheating, which is an evaporations, evaporative coolings and roof ponds and etc. And cooling roof, which is radial barrier, which is reflect about 70 to 90 percentage of solar radiations, about 50 to 60 degree Fahrenheit, etc. These are come some of the passive solar cooling here strategies. Now, here comes the key benefits and the measurable impacts. Here comes the 70 percentage of energy savings and the three CO2 reduction losses, CO2 emissions by one third of tons annually, and 76 degree Fahrenheit, which is a comfort range, which maintain stable indoor temperatures, and 5 percentage property value, which increases the value, etc. The passive solar designs, it is also provide thermal residential power outages. So these are the key benefits. Here comes the real world applications. Here comes the real world applications and cases. Here we had Beijing, UK, which achieves a 90% reduction in heating demands. It lies under passive solar and suspensions. California academic science, which reduce about 30% and saves about $4 billion years using natural ventilations. Here comes the zero energy home Zen active net zero energy consumptions which saves homes of 2 to 3 billion, thousand billions and annually. So these are the example demonstrations for the effective passive solar heat. Here, finally, coming to the conclusion. Uh, Here, coming to the conclusions, what happened is fundamental pillars. The passive solar design is a crucial for sustainable architecture and natural integration using natural process for effective heating and cooling and reduce reliance in achieve goals. So our goal is to essential for net zero energy and climate residential buildings. These were the main idea of this part, design thinking part. Here finally comes to the what about summary? So here we have in summary solar passive heating cooling systems. We have seen introduction, core principle of passive design, passive solar heating strategies, cooling strategies, benefits, real world application, and conclusions. So cooling strategies, we have natural ventilations, shading, evaporations, and coolings. And application, Benz UK, California, and zero energy home Zen. So these are the summarize, and I hope you understood this topic. Let's see in the next case. Thank you so much for watching. Have a nice day.